Okay, 3-7 day 2. I took the time to write out all of the derivative rules we've had so far. You don't have to write these down, they're going to be on your blue sheet. But just real quick, we've had 4 of them. The power rule, which is just when you've got x to a power, the power comes down, and x stays the same, then to the 1 less power. The chain rules that we worked on yesterday, where you've got a function within a function, and the thing to remember is we start from the outside and work our way in. So it's the derivative of the outside times the derivative of the inside. The order here makes a big difference. And then the 2 trig functions that we have derivative rules for are sine and cosine. And the derivative of sine is cosine, keep the angle the same, and multiply by the derivative of the angle. So trig functions kind of are a chain rule all on their own because the angle is the inside function. And then for cosine, the derivative of cosine is negative sine, keep the angle the same, and then again multiply by the derivative of the angle. So the angle is the inside, the trig function is the outside. And today's just examples. So let's first one. And this author is real big on doing things a couple different ways. So this first one, h of x equals the quantity 2x plus 4 cubed. We want to do this derivative 2 ways and show that they come out the same. Because before chain rule, we did this by expanding with Pascal's triangle. So do derive 2 ways and show that they're the same answer. Show that they are equivalent. Okay, so let's do this with our chain rule first. So by chain rule, we are looking at the outside derivative times the inside. So here's my inside, here's my outside. So I'm going to start outside with the power rule. So h prime of x. So the power rule says bring the exponent down as a multiplier. Keep your inside the same. To the 1 less power. Times the derivative inside. And the derivative inside, derivative of 2x is 2. The derivative of 4 is 0. And in terms of simplifying, we'll float the 2 to the front and have 6 times 2x plus 4 squared. Okay, before chain rule, we would have had this binomial. We would have had to expand it with Pascal's triangle so that we could do the power rule on each term. So we'll do that first. So with Pascal's, this is still going to be h of x, not the derivative yet. We're just going to take this function and expand it. You know it's going to have the 4 terms. I think I can fit them on here. The multipliers on that row are 1, 3, 3, 1. We've got a 2x that needs to be cubed, squared, and then to the first power. Then we've got a 4 cubed, squared, first power. So h is 2 cubed is 8x cubed. Here we're going to have 4 times 4 is 16 times 3. I don't even know, 16 times 3, 8. 48 x squared. Let's see, 16 times 6. 6 times 36. 96 x. And then plus 4 cubed is 16 times 3, 48. No. 16 times 4. 24, 64. Now we're ready for derivative. So we'll have 24 x squared, 96 x plus 96. 64, derivative goes to 0. Well, these are supposed to come out the same. That does not look anything like that. And the reason is that this is in factored form, this is not. So what we can do to make them look alike is expand this, since this is an expanded form. So we'll take our answer and expand. It's squaring it, so I'm just going to use the Pascal's triangle. So it's 6 times the 3 terms, 1 to 1, 2x squared, 2x to the first, 4 squared, 4. So this is going to be 4x squared. 4 times 4 is 16x. 16. Now distribute the 6. 24x squared. 16 times 6 is 96. X plus 96. Now they are the same. So I think you can probably count on one of those on the quiz. Given something, it'll tell you to do it with chain rule and with expansion first. Okay. So number 2. And today it's just going to be a little trickier, a little more involved. Y equals the quantity, the cubed root of 5x plus 3x to the 6th minus 2 square root of x, all that to the 4th power. Okay, you can definitely see you've got an inside and an outside when the parentheses are there. You know we're going to start with the outside, but these are going to have to be rewritten. You want to see fractional exponents instead of these root symbols. So I'm going to take the time to rewrite them. So this will be 5x to the 1/3. Ooh, that has an inside and an outside. This is going to stay 3x to the 6th. This is going to be minus 2x to the 1/2. I didn't have to put parentheses around this one because it was only an x on the inside. Here was the 5 and the x that were to the 1/3 power. Now I'm ready for derivative. Start on the outside. So the 4 comes down in front. The inside stays exactly the same. You have to have those parentheses there. Whoops, 1/3. 3x to the 6th minus 2x to the 1/2. All that is to the 1 less power times the derivative inside. This first term has its own inside and outside, so I got to do a little chain rule right here. So the 1/3 comes down. The 5x is to the 1 less power. 1/3 minus 3/3 times the inside. Inside derivative. Inside is a 5x, derivative there is a 5. So I got my outside and inside, now I get to move on. Here, derivative, I do power rule, 18x to the 5th minus 2 times a half is 1. X, subtract 1 from that, I'm going to have negative 1/2. Let's see, in terms of simplifying, but the only thing I can do is right here on this one. The 1/3 and the 5 can come together. I'm not going to, so I'm going to leave everything the same. 5x to the 1/3 plus 3x to the 6th minus 2x to the 1/2 cubed. This term, I cannot multiply by the 5 in here because it has that exponent on it. Just the 5 and the 1/3 can make 5/3 times 5x to the 2/3. 18x to the 5th minus x to the negative 1/2. And we're going to call that good. Seven sine of pi times x. Okay, I see a trig function with an angle. I know the angle is the inside, the trig function is the outside, so that's where I start. The 7 is a multiplier. Multipliers always just carry along. So the derivative of sine goes to cosine. I have to keep the angle the same. But then I multiply by the derivative of the angle. Remember, pi is a constant. That's like a 3x sitting here. Almost a 3, 3.14. The derivative of that would be the constant multiplier out in front because the exponent's a 1. So the derivative here is the pi. Pi is just a number, just as a symbol. So now bring that pi to the front so it doesn't get confused of being multiplied to the angle. 7 pi cosine of pi x. Okay, these last few are going to be, you have to get them in the right form before you can start doing your chain rule. So we've got f of x equals 1 over x squared plus 3x minus 1. Just slide that up before I forget. Okay, we have never done a derivative with the x's in the bottom of a fraction, and we still can't. But what we need to see is that we don't ever write them, but they're here. The parentheses are around this whole bottom, and it's to the first power. So what we can do is use our negative exponents to bring that up to the numerator, rewrite that with a negative exponent, and not have a fraction anymore. So this is still f of x. I'm just going to rewrite it. It's the quantity x squared plus 3x minus 1, all raised to the negative first power. Those are equivalent to each other. Now I can easily see that I can do the chain rule because I've got an inside and an outside. So we're going to apply a chain rule right here. Using the right notation, now I'm doing derivative. Negative 1 comes down. Inside stays the same. To the 1 less power, so that'll give me negative 2, times the derivative inside. So each term, that'll be 2x, plus, derivative here is 3, derivative of negative 1 is 0. So I think I'm going to leave it like that. I think the author does leave that down there, or it might come to the front with a negative 1. We'll see what habit he has in a minute, or actually when we check homework. Try another. Let's go. Let's see, do I want that one? Yeah. G of x equals 3 over x squared minus 3x, the quantity to the second power. Again, you don't have a rule for this. We've got to get that to the top. And we know you can bring that up and make it a negative exponent. So it's going to be 3 times the quantity x squared minus 3x, all raised to the negative 2 power. And now you can see a multiplier that I just carry along, but I've got an inside, outside. So derivative outside is the power rule. Gets multiplied by that constant that's being carried along, so I'll have a negative 6. Inside stays the same. 1 less power is going to give me negative 3. Inside derivative here is 2x, minus derivative here is a 3. And again, I could bring that to the front, distribute the negative 6 in, but I'm not sure we need to at this point. There. Okay, that's square root of the quantity 1 over x squared minus 2. Again, we've got lots going on here. We've got to fix this before we can start trying to do a derivative. We definitely have to get that x, the whole denominator, up to the top. But first I've got the square root on the outside. So if you remember, like fractions, you can take the square root of the top and the square root of the bottom separately.